Okay, Chapter 2, Review for Test. If a car is traveling at an average speed, so that's the average speed of 60 kilometers per hour, how long? So how long means I want to find time does it take to travel 12 kilometers. So this is just, we know that speed is distance over time. So time is just going to be the distance divided by speed, so it's just 12 divided by 60. And again, you can always 12 kilometers divided by 60 kilometers per hour. So 12 divided by 60 is equal to 0.2. Now, what some people are going to do, and this is second, so remember, physics is so great that I can carry my units through and cancel them. So remember, a kilometer divided by a kilometer per hour is the same as a kilometer times an hour over a kilometer. So these cancel, and I end up with hour, which is the correct unit. And I wrote seconds, but it was hours. When you're doing your test tomorrow, your FRQ paper is blank on the back. So what you should do is, when you have the test like this, you should turn over the back of the FRQ paper like this, side by side, to work out each problem, instead of trying to do it in your head. Now, the most common mistake people are going to make is, what they're going to do is, they're going to do the reverse. They're going to do 60 divided by 12, because they're going to make an algebra mistake. And if I did 60 divided by 12, and do you see the answer is 5? Is that one of the choices? It's always going to be one of the wrong choices. So the answer here was 0.2, so the answer was A. Number 2 says a runner completed the 100-meter dash in 10 seconds. What was her speed? So I know speed is distance over time. I don't even need a calculator. So 100 divided by 10 is just 10. Number 3, and what you're going to see is these multiple choice type questions, on most of them, you can do the math in your head. You won't even need a calculator. A truck with an initial speed of 12 meters per second, so VI is equal to 12 meters per second. You notice I'm chunking the problem. I'm not just reading the whole thing. As I read it and I get a number, I'm going to stop and I'm going to write down what that is. So it has an initial speed of 12 meters per second. Accelerates uniformly at 2 meters per second squared, so A is equal to 2 meters per second squared for 3 seconds. So T is equal to 3 seconds. What is the total distance, I want to find X, traveled by the truck during this 3-second interval? So here's my 4 variables, VI, A, T, and X, and I'm going to say which equation has those 4 variables. So it's X is equal to VIT plus 1/2 AT squared. I substitute in my values, so 12 times 3 plus, now I should be writing my units, so let me just do it. So it's 12 meters per second times 3 seconds. So look at my units now. Instead of me like doing on the side, this cancels with that, which is a meter, which is the correct unit, plus 1/2 meters per second squared times 3 seconds squared. So when I square the 3, I also square the second. So this second squared cancels with this second squared, and I end up with a meter, and then I can add them. So when I do all this, well, 12 times 3 is 36. 3 squared is 9, times 2 is 18, divided by 2 is 9. I can do this in my head, and this is 45. I don't even need my calculator. So the answer there is D. Number 4, an object uniformly accelerated from rest, so VI is 0, to a speed of 25 meters per second, that's VF. See how I just do it step by step? In 10 seconds, what's the acceleration? So now I'm looking for an equation that has these 4 variables, so that's VF is equal to VI plus AT. I want to solve for A, so I'm going to rearrange the equation to solve for the unknown in terms of the known. So VF minus VI over T is equal to A. So it's 25 minus 0 over 10 seconds. So 25 divided by 10 is 2.5. And a meter per second divided by a second is a meter per second squared. So that is going to be choice D. Number 5. It says two unequal masses falling freely at the same point above Earth's surface would experience the same, and that's the acceleration due to gravity, little g, because we don't take air resistance. As a body falls freely near the surface of the Earth, its acceleration, remember, little g stays the same. Which graph best represents the motion of a freely falling body? So remember, the first thing you need to do when you have a question with graphs is say, what type of graph is this? So this is a speed versus time graph. So a speed versus time graph, the slope of the line is the acceleration. So when an object is falling freely, what am I talking about? I'm talking about the acceleration due to gravity, which is little g. And we know that that stays the same. So on a speed versus time graph, little g, because it stays the same, it's going to be constant. Well, on a speed versus time graph, constant would be a straight line. So right away, I'm going to eliminate these curves. This shows a constant speed. So I'm going to eliminate this. So this is my choice, D. Okay, let's look over on the other side. Question 8. A 4-kilogram rock and a 1-kilogram stone fall freely from rest from a height of 100 meters. After they fall for 2 seconds, the ratio, well, because they accelerate at the same rate, it says what's the ratio of the speed? Well, they're accelerating at the same rate, so the ratio is going to be 1 to 1. Number 9, the graph at right represents the relationship between distance and time for an object moving a straight line. So on a distance versus time graph, anytime I see a curve, that means acceleration. So this is wrong. Now this is a positive slope, so this is a positive acceleration. Next one, which graph represents an object moving at a constant speed? So again, this is a distance versus time graph. On a distance versus time graph, the slope is going to be the speed. So it's a constant speed, which means it's going to be a straight line. Well, this represents something that's not moving. This represents something that's accelerating. This represents something going at a constant speed, but then it stops. So this is my answer here, is D. Number 11, the distance versus time graph at right represents the motion of a laboratory cart. According to the graph, the cart is, so this is distance versus time. The slope of the line represents the speed. Because I take the slope on a straight line at any 2 points on the line, it comes out to be the same, so I see that it's moving at a constant speed, D. So the graphs are pretty simple. All right, let's look at the next page. So the first part, it says base your answer to the following question on the graph below. So it says, which shows the velocity of a 1,500 kilogram car during a 20-second interval. So it says during time interval CD, what is the average velocity? Well, this is already a velocity versus time graph. So I don't find, here's CD, I'm not finding the slope of that because that would give me the acceleration. They want the average velocity. So the average velocity at C, the velocity is 10. At D, the velocity is 25, so the average is going to be 25 plus 10 divided by 2, so 35 divided by 2 is going to be 17.5. That's how I find the average. I just add them up and divide by 2. Okay, down here, it says base your answer to the following question on cars A and B. They start from rest at the same location at the same time. Compared to the speed of car B at 6 seconds, the speed of car A is, well, first of all, I don't even need to know physics. So at 6 seconds, here's reading the graph, car B is 10 meters per second, and car A is 8 meters per second. So the answer is less. So remember, car B is 10 meters per second, and car A is 8. So you just have to read a graph. You don't even need to know physics. All right, let's look at the next. Number 14. So it says the graph at right shows the relationship between speed and time for two objects, A and B. Compared with the acceleration of B, the acceleration of A is, well, this is a speed versus time graph. The acceleration is going to be the slope. Honestly, I'm looking at the choices. I see A has a greater slope because it's steeper, so I know that A is greater than B. But honestly, just glancing at it, I really can't tell if it's like 2 times as great or 3 times as great. So because I don't know that, I'm going to actually calculate the slope. So for A, I'll just take any 2 points. I'm going to do the one, I'd like to do the endpoints. So it's going to be 15 minus 0 over 2 minus 0. Remember, we're finding the slope of a line. Delta y over delta x is equal to y2 minus y1 over x2 minus x1. So I like to, if it goes to 0, and I pick that point instead of this one, because that one I have to kind of figure out, but this one's right where they meet, so that made it easy. So 15 divided by 2 is 7.5. So A, the slope is 7.5. For B, I'll do this point and this point, so it's going to be 10 minus 0 over 4 minus 0, so 10 divided by 4 is 2.5. So I see that this is 3 times as great. The last question says, which graph best represents the relationship between the acceleration due to gravity and the mass? So before we even look at the choices, let's think about this. As something gets more and more massive, how does the acceleration due to gravity change? It doesn't. It stays the same. Remember, little g is negative 9.8, so that means it has a constant acceleration. So as the mass increases, the acceleration stays the same. It's constant. So this shows as mass increases, acceleration increases. Forget that. So this is my choice here, D. As the mass increases, the acceleration is constant. And that's it for the multiple choice. Now remember, on the test, it's not the exact same questions, but the concepts are the same. So you need to make sure that you understand all these concepts. You don't memorize answers, because memorizing answers won't help you.